Welcome to this teaser on the AI planning course. What is this about? Well, many of the grand achievements in AI are in very specific domains, like chess. And then you get something that can play grandmaster scale chess, but that can literally not do anything else, not even Mau. Things have somewhat improved recently. You've certainly heard of AlphaGo and maybe of AlphaZero that can actually play 3 board games at grandmaster scale. Now that is a grand achievement, but it is still very limited in terms of generality compared to what humans can do. And so the question remains, how can we achieve a truly generic form of problem-solving intelligence? This is the question we consider in AI planning in the context of single-agent search problems, which are characterized by an initial state, a set of actions, and a goal. The task is to find a sequence of actions that takes you to the goal. And we formulate this in a manner so generic that it encompasses not just this game that I'm showing you here, but also applications as diverse as natural language generation, business process generation, and security testing. And all of this is done in one and the same framework. So it's very powerful. It's a quick method to get something up and running in your application. It is obviously very flexible. It is also clearly a very strong form of intelligence. The big problem is complexity. Those problems are very hard to solve. They got huge state spaces. And when humans build effective solvers for those problems, they always build in deep domain knowledge or deep engineering knowledge. And the question is how to do without that. How can we achieve all of this fully automatically? We will look at methods towards this end in the course. We will mainly focus on heuristic search, which has been the most prominent and successful paradigm in AI planning in the last 2 decades. The principle is quite simple. We start at the initial state, we search towards the goal. We have to avoid exploring the entire state space, which would be infeasible. To this end, we employ a heuristic function. This is a function that maps states to numbers estimating the distance to the goal or the remaining cost to the goal. And then the search simply prefers states that appear to be closer to the goal. The big question is, where do those heuristic functions come from? Because we have to create them fully automatically. We will see 4 principles in order to achieve this. One of those principles is the delete relaxation. It works as follows. Let's say you want to buy a car. After you bought the car, you have the car, but you don't have the money anymore. Under the delete relaxation, you buy the car and you have the car, but you also still have the money. Now, if you think about this for a moment, the world turns completely crazy. You can earn a salary once and then live the rest of your life from that one salary. Remember that we're only using this relaxation to compute an estimate of how difficult it is to solve the real problem that we actually want to solve. Another principle for computing heuristic functions is abstraction, where we superimpose an equivalence relation over the state space. The question then is, how can we do so without having to actually compute the state space in the first place? We will see 2 methods for doing so. One method are pattern databases that project the problem onto a subset of its specification. We will also do some interesting theory in the course, but the main focus is more practical. In particular, in the programming exercises, you will build your own planning system starting from a code base we provide. And you can actually pick your favorite subset of the techniques we will introduce in the course. And then at the end of the course, we will actually run a competition among the student planning systems, running your systems against each other on a set of benchmarks. When you're faster than the others, you get points. The more points you have, well, the more likely you are to win. And there will actually be a small prize for the winner. And that's it. I very much hope to see you in the course.